Okay, so linear factors went really well. But what happens in this screencast is we do a couple of examples where we're going to use partial fraction decomposition, and fractions aren't as scary as we think they are, where things get a little bit tougher to work through. What about the integral of 3x squared plus 4x minus 9 over x minus 1 times x squared plus 2x minus 4 dx. So this is not linear, and it doesn't factor into linear factors. This is what we call an irreducible quadratic. So how does that change the process? Well, it is still true that two proper fractions whose denominators are these factors will add up to this proper fraction. This is a proper fraction because the denominator has an x cubed and the numerator has no power bigger than 2. So what happens over here? Well, this has to be a proper fraction, which means that this can't have an x to the 1, so it has to be a number. And this has to be a proper fraction, so this can't have an x to the 2, but it could have an x to the 1. This is a linear factor. Now we just have to figure out what a and b and c are. So how do we do that? Well, we multiply everybody by everybody else's denominator to figure out what the numerator is when we combine the fractions. And that numerator on the left is equal to the numerator on the right. So now, time for some strategic substitutions. One of the substitutions is obvious. If x is 1, then this whole factor drops out, and we get 1 plus 3 minus 4, that's negative a, that's 3, plus 4 minus 9 is negative 2, so a is 2. The others are less obvious, so let's pick a number that's easy to work with. If x is 0, then this drops out, and we get 0 plus 0 minus 4 times a, that's 2, plus 0 plus c times negative 1 equals 0 plus 0 minus 9. And this tells us that c is 1. And then the third substitution can be any number you like. I chose x equals 2, and when I chose x equals 2, I solved an equation and came up with the fact that b is 1. And so that means that this integral is the same as this integral. The x minus 1, it's a over x minus 1. That's going to be easy. And it's going to be x plus 1 over x squared plus 2x minus 4. And that's not bad, because if u is x squared plus 2x minus 4, then du is 2x plus 2 dx, and that's just twice what we see here. So this turns into 2 ln of absolute value of x minus 1 plus 1/2 ln of the quadratic plus a constant. We can handle irreducible quadratics. And then the other thing to consider is what happens if the fraction isn't proper. The numerator has a higher power of x than the denominator does. What do? Well, we divide. We go all third grade long division, and we divide. And we ask ourselves, how many times does x squared go into x cubed? And that answer is x. And then we multiply like we did in the third grade. And then we subtract like we did in the third grade. These go away. That's 4x. We bring this down. This is of smaller degree than this is, so we're done. And we turn this into the weirdest mixed number we've ever seen. This is the integral of x plus the fraction remainder over divisor. And then this is a partial fractions problem. It's a partial fractions problem. X minus 2 and x plus 2 are the factors. We run through the process we have from before, and we find out that this is 9/4 over x minus 2 plus 7/4 over x plus 2. And then we just integrate the integral of x, the integral of 9/4 over x minus 2, and the integral of 7/4 over x plus 2. And we got it. So really, this is a lesson in how algebra bails out calculus. And I hope that these examples are helpful.